In the previous exercises, you wrote a Hello World program, and then with MPI init and finalize init, and you saw that if you run them in parallel, there is no essential difference between the processes. They all execute the same statements and they run more or less at the same time. So suppose you want to actually do something useful in parallel, take some work and divide it between processors. How do they get to behave slightly differently? Okay, here's a first MPI routine. It's called MPI get processor name. And so if you run your code on multiple processors, they will actually display slightly different internet names for the processors. Okay, so in between your init and finalize statement, use the routine MPI get processor name and get the character string with the name of your process. And run your program on a cluster that is large enough that you can indeed see that you get multiple different physical processors. Okay, about this routine. In C, it looks like MPI get processor name and character star and int star with the resulting length of the name. Likewise, in Fortran, you give the name, which is a character buffer and an integer parameter, and in Fortran you get the extra parameter for the error code. Note that the character buffer is not allocated by the MPI library. It is allocated by you and given to this routine, and then the MPI routine puts some content in it. Okay, what I'm showing you here are not bits of pseudocode that you can cut and paste into your program. What I'm showing you here is a prototype of the routine. So that is how the routine is defined and how it appears in a .h file, not how it appears in your code. So if you're writing C and the prototype says int star and procs, then you need to define an integer and pass that in with an ampersand. If your prototype says int routine name, and that means that when you call your routine, you can catch the result in an integer parameter. In Fortran, the pseudocode and the code looks slightly differently, but the prototype will contain the integer and intent and other annotations on the variable declarations. So they appear in how I describe the routine. They do not appear in your code. And of course, if I give a prototype for a Fortran routine, then you need to insert the call keyword to call that routine. Python is a bit more complicated. We'll get to that when we see Python routines.